Hi, in this segment I'm going to introduce the two tasks of named entity recognition and information extraction, methods for getting simple structured information out of text documents. Let's start with information extraction. The goal of information extraction systems is to find and understand limited relevant parts of a text. And normally we're going to run it in a context where the system gathers information across many pieces of text. And the goal of doing this information gathering is to be able to produce some sort of structured representation of the relevant information. So you can think of it as instances of a database relation, so rows in a database table, or as a knowledge base. And when we do information extraction, we can have one of two goals. One goal is to directly help people to organize information so that it's useful to people. And the other possibility is to put the information in semantically precise form. So commonly, computers for other downstream information processing tasks won't be able to perform them if the input is just natural language text. But if we can have pulled out various kinds of relations, such as a database table, then it's very easy to do subsequent data mining and processing. So the kind of information that IE systems extract is clear factual information, the kind of who did what to whom, when kind of information. So let's take a look at an example of that. So here are a couple of examples. One's gathering earnings, profits, board members, headquarters, any of this kind of factual information about companies from company reports. So the idea is that the system can look through the text and then it sees, okay, here's the name of a company, and then it's talking about its headquarters, and it says that the headquarters are located in, so that's kind of an indicator of a headquarters location, Melbourne, Australia. And what we're going to get out of that then is this relation, which you can think of as an instance of a database table. That's only one example. There are lots of other examples. Another example is this one that I show here. There are lots of cases in biotext mining, so learning drug-gene product interactions, learning subcellular localizations, lots of relations of interest to bioscientists in various ways have been worked on in information extraction systems. In the more consumer space, information extraction is now available and I think popular in various applications like either Apple or Google Mail, or is used in web indexing. So here's a little example from Apple Mail, and so here there's this date, and so Apple Mail recognized that there was a date there and put in that little arrow box. And when I hold that down, it's then offering to create a calendar event for me. And so that's kind of a little help of now allowing me to do that kind of task faster. This kind of information extraction is often fairly simple and seems to be mainly based on using the kind of regular expressions that we saw earlier, including name lists. Here's one more example about how companies are starting to surface information extraction and search applications. So if I stick into Google BHP Bulletin headquarters, as well as regular web search results, that is actually giving me right here, best guess for headquarters is Melbourne, London. Of course, we can argue a little about whether that's the perfect answer. They're really kind of two separate answers here. BHP Bulletin's actually kind of a complex case because they have this complicated dual company structure, and there is a Melbourne office and a London office. So we'll call that, just about correct. Okay, that was information extraction. Let me now go on and look at a particular subtask that has become very important, named entity recognition. So the idea of named entity recognition is that we're going to, in particular, just look for and classify names in a text. So the first step is we find names. So here we've then found a name, and in particular what that means is we're finding the limits of the name. So this one is these two tokens, this name is this one token, and then once we've done that, we're going to classify the names So we're going to say that this name here is a person name, this here is the name of an organization, this is a date, and then we have a sequence of further person names. Sorry, I guess this one's Rob Okershot and goes across the line break. So to say a little bit more precisely what the task is, we have this sort of phrase of named entity recognition, and it's a little bit of a code word these days that reflects the history. The idea of it was that entities were meant to refer to discrete things in the world. So I am an entity, Stanford University is an entity, but something like sand or air isn't an entity, that there's not a specific delineated physical thing. And then the idea of named were that some entities have names. So I, Christopher Manning, have a name, but the chair I am sitting in as I record this, it is also an entity. It's a discrete physical thing, but it doesn't actually have a name attached to it, so it's not a named entity. That's the kind of philosophical history. In practice, as the word is used in named entity recognition, that's not quite what it means, because effectively what we're doing is using named entity recognition to mean easily distinguishable names or other things in text that we can pick out. So in particular, 2010, so things like dates, times, quantities are normally regarded as named entities, although according to the original starting point of the name, something like a date or a chemical or a protein isn't actually an entity at all, but we always include those kinds of things when we're building named entity recognition systems. Okay, so what is the use of named entity recognition systems? Well, named entities, if you identify them in a text, there's something that can be indexed or linked off. So as I note down below, many companies make use of various techniques for tagging entities on web pages, and then they can provide links off of those entities to bio pages or topic pages or other things of that sort. So there are a whole bunch of commercial products that run as web services that allow you to do that kind of thing. If in general you want to be crawling the web and picking up sentiment, we discussed earlier detecting sentiment as to whether it's positive or negative, but you will then also need to work out who the sentiment is about or what the sentiment is about. And so at that point you need to be picking out the company or product names in the text, and that's a task of named entity recognition. But there are a lot of other uses where named entity recognition is a subcomponent of a larger task. And so commonly, when you're doing information extraction, a lot of what you're doing is actually identifying named entities and then working out the relationship between them. So we'll talk later about question answering. And in question answering, for various kinds of questions, often the answers are named entities. When did something happen or who did something? And so it helps a lot for question answering if you have good named entity extraction. Another example that we also saw of how people use named entity recognition that plays off this having semantically interpreted information is to use it in then various kinds of things like calendaring applications where you're making use of the semantic interpretation. Okay, I hope that's enough to have given you guys a good sense of these two tasks. Named entity recognition of simply picking out concrete names of objects, people, organizations, etc., or quantities, dates, times, and things like that. And then the bigger task of information extraction, where the goal is to pick out particular relations, rows in a database table from pieces of unstructured natural language text.